Uh, Hello guys, here we are again. So today we are going to just continue our long road toward this shortcut method to find PI for non-homogeneous high order differential equation with constant coefficient. Okay, now see, the second method, suppose we have here, this is homogeneous, okay, high order differential equation. This is constant coefficient, high order differential equation. But this is this is a non-homogeneous, okay, non-homogeneous high order differential equation. Why? Again, because here our g of x, okay, is a function of x and it's not equal to 0. If this g of x would be equal to 0, so we could say that this is homogeneous function, then the cf or yc, or if we can say a complementary function, should be the only solution for this differential equation. But in this case, we have the two component of a high order differential equation solution. Okay, because the solution of a high order differential equation is always expressed in two ways. The first way is for complementary function, that is yc. Okay, and here we have found this one. Now we are finding different ways. We are finding our PI, that is particular solution. As we know, the solution, or how can I say, the high order differential equation is expressed in two solutions. The first solution is yc, and the second one is yp. Okay, yc complementary function, and yp is the particular integral, like this. Okay, the general solution, okay, general solution for a high order differential equation is equal to yc plus yp. This one we know how to find. Now we are trying to find yp, that is our particular integration. So to find yp, we have many methods. So we are going to go through this one. So here we are in case number 2. We are going to solve this case number 2, then case number 3, 4, and 5. Then we will go to this variation parameter method, and also to this undetermined coefficient. Okay, just stay with us. See, for this third case, or for this second case, here we have a high order differential equation with constant coefficient, and here we have g of x. For this second case, here our g of x is a function, is like g of x is sinus of ax plus b, or it can be cosinus of ax plus b. Now, how to solve this one? Yeah, here to solve this equation, what you have to do is almost the same that we did when here g of x was something like Euler raised to ax plus b. So what we have to do, we have just to substitute where we have d square in this function, not d. Okay, we have to substitute where we have d square by minus a square, just like this. So here, whenever I have gx equal to this one, so you will do just this substitution directly. Your pi will be 1 upon, okay, f of d square, okay, time this g of x. G of x can be sinus of ax plus b, or cosinus of ax plus b. Now see, okay, just be aware about this. Now see, here you will substitute. You have to take out the function of d, okay, and make it like a function of d square, so that you can substitute where you have d square, you will substitute by minus a square. Okay, that's the point. So here you will put just d square where you find d square, okay, just like this. F of d square must be equal to f of minus a square. Okay, just this one. So d square you substitute by minus a square. That's the point. Now, if suppose I substitute this expression, like where I have function of d square, I put minus a square, what will happen? Now suppose I put here and it is equal to 0. Okay? The general rule is this one. Just substitute minus a square where you find d square, and that's fine. This is the general rule. So just be reminded that when I have something like 2 square minus 2 square is totally different than, minus 2 is totally different than minus 2 square. here it's equal to minus 4, and here it's equal to 4, because 2 here, this exponent is out of the bracket, and here we don't have exponent here. Okay, this exponent is just linked to this 2, so this minus will not change anything. Okay, just like this. So just be aware about this. Okay, yeah. Now see, the question is like whenever you have this one, this happens when, okay, I can substitute this one, okay, only when this guy is different to 0. Okay, so suppose I just substitute, I see what is a here. I go to the function, through the whole function, I look for d square. Where I find d square, I will substitute by minus a square. Okay, this a is the coefficient linked to x in this function. I will just substitute, and that's fine. Now, suppose I find here the a square that I'm substituting here is equal to 0, is making this equal to 0. So it will bring us another like, I will just, this is the general substitution, okay? But when, if you substitute this one, okay? If this one is different to 0, just substitute and that's fine. But if you substitute this one, the question is, okay, substituting this one, and you get d square, f to d square, f of this square equal to 0, it means that, it means what? Okay, you will just check, okay, you just check your pi will be given, okay, as we know we have to multiply by x, then divide, then derive the term of f of d like x. If it is derived 1, okay, if it is just suppose you put d square, okay, like f of minus a square, and you put there in the function, and it gives you 0, and this expression gives you 0. So it means that you will have to add x and derive x one time. And if it repeat infinite time, I'll get x raised to n, and here f of d square raised to n. Okay, where n is the order of my derivative. Okay, yeah, the differentiation order is given by this one, time, okay, time this one, this time what? Time g of x. What is g of x? G of x is your cosinus, your sinus, and so on and on. Okay, yeah, it can be your cosinus, your sinus, ax. Yeah, I will just write g of x for this case. Now see, okay, this is like the general way you can go and so on and on. Okay, but this is the general way. So whenever I substitute minus a square in the place of d square of this function of d, I will get, and I get 0. I have just to multiply by 1 time here x, and here I will derive 1 time. Then I substitute d square. Okay, I substitute where I have this square, I substitute minus a square. Then if I get again 0, I will do the same. But the point here is that it's like sometimes you got awkward doing this one. So there is a general, okay, rule also. Okay, I will call this one a particular case. Sometime we have a particular case. So okay, there is a formula like we know that in this case the general way to write for this one is whenever we have like d square, okay, plus a square raised to r. R here is the exponent of this whole expression, and here we have sinus of ax plus b, or it can be cosinus of ax plus b. See, here what you're going to have, how to find pi, that's the point. For this expression, if you see closely, you will understand that here this a is the same of this a. Whenever you substitute this a here by d square, here d square is this. So if you substitute minus a square in place of d square, it will be 0. And it will be repeated r time, many times. In these times is r. So whenever we have these expressions like this, so it will be given, okay, I can just calculate this one, pi of this one, directly by minus 1 raised to r, okay, x raised to r, all upon what? All upon okay, all upon what? All upon 2a raised to r, okay, 2a raised to r, and here r factorial, then time sinus of a x. If it is sinus of ax, suppose, okay, sinus of ax plus r pi by 2, okay, if it is sinus. So if it is cosinus, then you substitute just here, you can put cosinus of ax plus r pi by 2, okay. Yeah, this is the general way to write the solution for this case, okay, most of this time. Okay, sometimes you get something like this. So the most important here is first make a function, make this function of d, f of d, a function of d squared, okay, then substitute your d squared by your minus a squared. Okay, what is minus a? This one and this one. Okay, so this particular case can be found by using this term, this rule. It's okay. This is just a kind of generation. This one from here we can get this one in a very easy way. Nice. So let us just solve some exercise. Maybe from there you get more applicants and more clear idea about this one. Okay. Yeah. Suppose we have different. Okay. Now see here. Look at the board. We have brought some different cases, and we are going to analyze. Okay, one by one. Okay, by applying only this case number 2. Okay, just see here we have this is the first one. Okay, y dash plus 4 dash equal to 2 sinus 3x. Okay, when to apply case number 2? It is when you have here, when this g of x, when the function outside of this one, when this function of x is equal to sinus or cosinus. Okay, so that's the point. Now see how to solve this one. We have y double dash plus 4 dash equal to 2 sinus of 3x. Okay. The first thing is, like, write the auxiliary equation of this one. What will it be? It will be d squared plus 4, okay, 4d, okay, and this is time y is equal to 2 sinus. What is your sinus? Like 2 sinus of 3x. Now next, see, as we know, we have to find a function of fd square so that we can substitute minus a square in the place of d square. Okay, that's the point, to find this pi. Okay, yeah, just remembering you. Okay, this one we will apply after all. Now see, the first one here, find your yc. What's your yc here? Your yc will be given by what? By this auxiliary equation. So just write your auxiliary equation. What will be? D square plus 4d, okay, equal to 0. Then from here you can just solve this one, and that's fine. Now you get here d is equal to 0 or d is equal to minus 4. So your yc directly will be equal to, these are two roots and they are different and they are real. So Euler raised to 0x times c1 plus Euler raised to minus 4x times c2. This is your yc, okay? But this is not important. This is important, but not that much important for us. So we are looking for yp. Euler raised to 0, it will be c1 plus Euler raised to minus 4x c2. Okay, c2. This is yc. Now let us find what is yp. Okay, so yp, as we know, will be 1 upon f of d square times g of x. And we know what is our g of x. g of x will be equal to sinus. So substitute here, sinus of 3x. Okay, this is f of d squared. Now see, look at the auxiliary equation, d squared plus 4d, right? Just write here down, d squared plus 4d. Now substitute where you find d squared, you will substitute here 3, okay? But this is not only 3, this is minus, because a here is 3, minus 3 squared, okay? Substitute here, 3 squared. So yp will be equal to 1 upon, here I will substitute by minus 3 squared. Minus 3 squared plus 4d, okay? Sinus of 3x. And this, okay, here your yp will be equal to, just check here, will be equal to minus 9 plus this one. So it will be 4d minus 9 sinus 3x, right? Now see, as we know, whenever we have sinus or cosinus, here I have to substitute 3 in the place of d squared. But this one is not d squared. So we have to make this expression look like a d squared. And how to transform this one? That's the question. How to transform this one? So we have to multiply, okay? Just multiply and just multiply by this conjugate and divide by it then, okay? Just something like this. We will multiply this one by this guy. So this is 4d. If I want to make this guy square, I have to multiply by 4d plus 9 so that I can have a difference of quadratic expression like a minus b and a plus b. You know this one, a squared minus b squared. That's the question what I want to. So I will just multiply 4d plus 9 all upon, I will multiply then, okay? Multiply and divide. When I divide this guy, this will be multiplied by this the same, so it will be 6d squared minus 8,1. And here it will be sinus of 3x. Okay? So from there, yp will be equal to, take this guy out, okay? 4d plus 9. Take this guy out, and here you get 1 upon this expression. Now see, now that I have this one, this square here, I can just substitute directly, put this 3, okay? Minus 3 square is equal to d square. So I can just substitute this one again. So I'll get 16 times minus 3 square. Minus 3 square, okay? And here minus 18. Are we together? Yeah. From here it's fine. And here it is sinus of 3x. So yp will be equal to this expression. This is number. You have just to multiply 9 times 16. Okay. 9 times 16, how much is this? Like, yeah. Just multiply this one. 9 times 6. So 14, 45. 45 plus 9. Yeah, 54. I guess this is 54. Then this 4 come down. This 5 go there. Yeah. 5 plus 9. And this will be this expression, 144. So 144, then see here, this will be negative. This will be negative also. So you are going to have something like this, 4d plus 9 times 1 upon 144. It's negative, and this negative 81. And here it is sinus 3x. Okay, that add this one, 144, 81, 5, 12, 2, 2. This will be 2, 2, 5. Okay, so now from here you are going to have 4d plus 9 multiplied by sinus of 3x. Okay, all of this by minus 2, 2, 5. Okay, now see, here we know that d is the differentiation operator. Just apply this differentiation operator in sinus, and here do this time this one. Okay, just you're going to do what? Here just apply like a distributivity like of this function. So like this time this and this time this. Here it is operator. It means d, we know d is what? D by dx. Okay, if I just substitute and multiply by sinus, I'll get this one, sinus 3x. And 4 can be outside because 4 is a constant. Then derivative of sinus 3x, this is what? This is 3 cosinus of 3x. Time this 4 outside, this will be 12 cosinus 3x. So here I'll get 12 cosinus 3x. Okay? 12 cosinus 3x. Then this guy times this will be the same. Okay? Plus 9 sinus 3x all upon, okay, all upon what? Minus 2 to 5. Okay? And here, just do some simplification. You will end with something like minus, okay, 1 upon 2 to 5. And then you are going to have 12 cosinus of 3x, okay, plus 9 sinus of 3x. Okay, this is your yp. Okay, I will write here yp will be minus 1 upon 2 to 5, and here 12 cosinus of 3x plus 9 sinus of 3x. Okay, that's the expression. Okay, 12 cosine of 3x minus 1 by this one. Now if you join your yp and your yc, this will be the solution of this equation. Okay, the general solution will be this, okay, plus this one. Okay, if you just join this expression and this expression, you are going to have your expression at all. Nice, and you're done. Now let us jump to the second exercise. Okay, it's here. In this second exercise, what you have to see is, okay, let me just erase it out. Okay, so for the second question, you have now this d squared plus 1 y is equal to sinus square of x. Right, so what you have to do, here I have sinus square of x. And sometimes you're going to have expression like sinus cubed, sinus raised to 4, 5, 6, 7. There is a way also, there's a way always to reduce the power of this sinus. And how do we reduce the power of the sinus? We reduce the power of the sinus, use equivalent formulas. You know that cos of 2x is equal to what? Cos of 2x is equal to cos of x plus x. And this one, if you apply sum of angle for cosinus, you are going to have cos of x times cos of x minus sine of x times sine of x, because here cosinus is like is a even function, but sinus is odd function. But yeah, so here you have like cos square x minus sinus square x. Okay, now that you have this one, this is equal to this cos 2x. This guy is sinus square, right? So we can express, there is a way to express this cosinus in the place of sinus. So we can express this one as 1 minus cos square x minus sinus square x. Okay, the same way I can change sinus and find wherever sometime I got something like cosinus square, I can also find cosinus square in the place cosinus square. I can reduce the power of this cosinus or sinus applying these formulas. So by this one, what you're going to have, here it is 1 minus sinus square. Okay, this cosinus square is equal to this. This is equal to this. So 1 minus 2 sinus square of x is equal to cos 2x. This guy, okay, just send this one out. It will be cos 2x minus 1. Then this minus go down, minus down. So it will be sinus square of x. So this minus will be here and will be here. This will be 1 minus cos 2x all upon 2. This is equal to sinus square of x. That's the way we reduce the power of sinus or cosinus. Even if it were raised to 4, I would just go to this one. Suppose here it is raised to 4. I come just here and just do this one, raised to 4, and here raised to 4, right? And here I will get something like 1 minus 2 cos 2x plus cos 2x square all upon 2. And here this cos square, okay, this cos square is the same. I will apply for this guy the same rule, like cos square of 2x will be equal to what? Cos square of 2x, okay, will be equal the same, okay? I will just apply what? How to reduce cos square of this one, okay? Cos square of this one, you know that cos 2x, okay, cos of 2x, suppose I have 2x here. 2x will be equal to what? Is equal to cos square of x minus sinus square of x, okay? Yeah, the same thing you will apply here. Now suppose here you have 2x, okay? Just cos of 2x is equal to this one. Now I have to find what is cos square. If I have to find cos square, I'll do this one. Cos square of x minus, and here I'll get 1 minus cos square of x. See? Here I'll get 2. This is positive, negative. 2 cos square of x minus 1. And here it is cos 2x. Send this guy out. You are going to have 1 plus cos 2x all upon 2 is cos square of x. Now see, here it is for x equal, like here is 1 and here it's 2, right? Now put where you find 1, put 2 as here, 2 here, and here put 2. 2 by 2 or 2 times 2, it is 4. It means that cos square of 2x will be 1 plus cos of 4x plus 2. And you can come here and substitute. So sinus raised to 4 of x, okay, this one will be 1 minus 2 cos 2x all upon 2. And here, just substitute here, I'll get plus 1 upon 2 and plus cos of 4x by 2, okay, by 2. It is sinus raised to 4 of x. Okay, so this way just go and solve this one, and it will be 1 minus 2 cos of 2x all upon 2 plus here it will be all upon 4. 2, 2, 2, 2. 1 plus cos 4x. This is sinus raised to 4x. You see, that's the way we do, okay? That's the way. We can reduce any power of sinus and cosinus into, we can reduce the power of the sinus and cosinus, okay? Okay, but for that, you have to know a bit of trigonometry and these basic concepts. Now see, here we have this expression. So here we can change this f of g of x will be 1, as we saw there, 1 minus cos of 2x by 2. And here, d square plus 1. And here it's y. Now see, this expression is like this, fine? Okay, this is fine. How to solve this one? First find your yc. Your yc is this expression. We know that here I'll get 0x, and here c1 times cos of x plus I c2 sinus, okay, sine of x, also a solution. Okay, here it will be imaginary number, and the root will be I and minus y, minus I, okay, plus or minus I. So as I know, here there will be no, how can I say, real part, so it will be 0 for real part, because here d1 and 2 will be plus or minus I. Okay, 0 is the real part, that's why here 0, and that's fine. Now let us solve for yp. What will be yp? As we know, we have just to write all the expression here, this function of d down there. So this will be d square plus 1 times your g of x. G of x is this, so this will be 1 plus, 1 minus cos 2x all by 2. Now see, this is expression, okay? Now we have to apply, just apply this operator function in this one and this one. So your yp will be 1 upon d square plus 1, okay? Plus 1 for this guy. And 1 by 2 can be written yp This is 1 by 2. And here, for the second, minus 1 by 2. And then I will get 1 upon d squared plus 1 times cosinus of 2x. Okay? Now see, here there will be no need to apply this rule because there is no cosinus. Here you can apply the, how can I say? You can apply the first case, that is Euler raised to 0. Okay, here you can just come here, 1 by 2, and here I'll get 1 upon d squared plus 1 Euler raised to 0x. Okay, then substitute here by 0, put here 0, and see what you're going to have. Okay, put here 0. Let's see what you're going to have, and that's fine. Okay, yeah. Then minus 1 by 2, and here, wherever you see the function of d squared, put minus a squared. Okay, so you're going to have, put here minus a squared. You're going to have what? Minus 2 squared. A is here 2, and plus 1. Then cos of 2x. Okay, now see, yp will be 1 by 2. Put here 0. Okay, it will be 0. It will be 1 only. So time 1 minus 1 by 2. And here, what are you going to have? You are going to have minus 3. So minus 3 times this minus 1 by 2, it will be plus, and here will be 6, and this will be cos of 2x. Okay, so general way, yp will be 1 by 2 plus 1 by 6 cos of 2x. Okay, done. Okay, if you want to find what is the solution, general solution for this case, now you know the general solution for this case will be this expression. This will be 1, okay? Will be C1, okay? Will be this expression here, okay? This one and this one. Just put them together, and this is the general solution for this case. Okay, let us jump for the next one. The third exercise, this is this one, okay? And then we will jump to the fourth one. Hope you may see and understand and just clarify your ideas about this one. Okay, yeah, that's the point. For the case number 3, it is y 4 times, okay, minus y. It's equal to sinus x and cos of 2x. Now see, here you have this expression, right? Now see well. Just transform this guy, raised to 4 minus 1. And here it is y. Just be careful. Here the only order of derivative is 4. Okay, yeah, just be very careful about this one. Yeah, this is very important to deal with. This one and this one. Then this guy is sine of x, then time cos of 2x. Okay, that's the equation. That's the expression. Now see, for this equation, how to find the solution? Okay, first be aware about this guy here. Okay, this guy here. This guy here is not in, how can I say, in reduced order. Because we only know that to get this, to apply the second case, this one must be only cosinus of 2x, 3x, and something like this, and not a multiplication of 2 cosines. So if it is a product, I have to split it and transform this guy as a sum of cosinus and sinus. And we know, okay, to transform this one, you just have to be careful. What is, suppose I have this formula, sinus of a plus b, okay, and cosinus of a plus b, plus or minus, plus or minus. So we only have this combination, sinus and cosinus, when we play this function sinus, of sinus, okay? Yeah, only. Because with this guy, we only have a combination of cos and or sinus and sinus. But whenever we see combination of sinus and cosinus and they are product, so it means that they sum 2 angles, and this angle are based upon this are based upon this sinus. This is sum of 2 different angles of sinus, okay, with respect to sinus. So it means that whenever I have this one, it will be sinus of A and cos of B plus or minus sinus of A and sinus of B and cos of A. Okay, but for this one, it is cos of A, cos of B, minus plus sinus of A and sinus of B. So as you can see, never it will be, if I have sinus time cos, so sinus and cos will be generated by the sum of these two expressions, okay? And cosinus and cosinus, sinus and sinus will be generated by using this one. It will be sum of this. So by seeing this, I can just directly come here. This is 1 and this is 2. So see, it is the same as I put like x, just do this, x plus 2x. Okay? Then put here plus or minus sinus of x minus, okay, 2x. You can just do this one. Okay? You can just change the order. You can put 2x minus x and there and so on and on. It makes no problem. The only thing you have to understand is if you are doing whatever randomly, just be aware that here this is minus, this will be negative. Sinus is a function, it's an odd function. So you have to be aware that this minus will be down out there. So if you see, if you just split this one according to this one, you are going to have sinus, sin x, and cos 2x. Then plus sin 2x and cos x. Then put plus or minus. And here split also sin x and cos 2x. Then plus, no, it will be not plus. See here. It will be what? This will be plus, minus sinus of x, because here it's minus, then it's minus. Minus sin of x and cos of, sin of 2x, okay? 2x and cos of x. Now see, if you add, you just try. If you add them, you are going to have sin of 2x. If you add them, just add them. Okay, if you add them, you are going to have this is 0, this and this will be cancelled out. And you are going to have this and this. Just compare. It is equal? Right, it is equal. So the only change is that here I will have 2 times. Okay, this and this will be 2 times sinus of x and cos of 2x. How if I didn't found this one? You just try with minus. Put here minus. Okay, if you put here minus, then go. You are going to have here this and this will be cancelled out, but this one will be positive and this one will be positive. Then you are going to the opposite side. Okay, yeah, this is a basic concept about trigonometry, so this is very important. So this one means that I get 1 by 2, and this will be sinus, the sum of them, like you can just sum 3x, and here it will be plus, as we saw there. Okay, it will be plus what? Plus sinus of the difference of this angle. Okay, the difference of these two angles will be what? I sum first. Okay, I sum first, then the difference will be minus x, because x minus 2x minus x. As we know, this sinus is a function what? It's an odd function, so this minus will be here out. Minus, just like this. Okay, that's the way. Now that you know this one, so here it is d raised to 4 minus 1, and here 1. See, this raised to 4 minus 1. This d raised to 4 minus 1. Okay, find first what yc. Yc, okay. How to find yc? Write the auxiliary equation. Okay, auxiliary equation. What will be the auxiliary equation? D raised to 4 minus 1 equal to 0. So for this one, how to solve? That's the question. How to solve this expression? So it is 4 root. There is 4 root for this one. This will be d squared minus 1. Just transform it in a, as you have 1, you can shape it. You can give it exponent, whatever exponent that you want. Like suppose here it is 4, right? So it is d raised to 4. And I can just make this one, it's a difference of square, like this one, like this. And here you can just apply, split it, okay? Just split it. It will be d square minus 1 and d square plus 1 equal to 0. Now, this expression right here, this is also a difference of sum. This will be d plus 1 and d minus 1. But here, you are going to have two different d's, okay? Like d plus I and d minus I. And it's equal to 0. That's the expression. See, d plus I, d minus y. How? That's the point. Here you have d squared plus 1. So you can just change also minus I squared. This will be 1, right? Because I squared is 1. So this will be d plus I and d minus I. Okay, now you have all the roots here. This is pair of roots, imaginary roots. You know the solution for this. And this is pair of real roots. You know the solution for this. So yc will be equal to, for this one, Euler raised to x c1 plus Euler raised to minus x c2, okay? Then plus Euler raised to, here we know there is no real number for this imaginary roots. So 0x times c3, and here cosinus of x plus I c4 sinus of x. Right? Then from there we can see that this will be 0, so no need to write this guy. This will be 1 here, okay? This will be 1, so this is the yc. This is your yc. So c3 cosinus of x plus I c4 sinus of x. Okay, this is your yc. Now how to find yp? That's the question. See, here we have this one and this one. To find yp, we have just to go. Let's go for this one. Yp will be 1 upon, here the d expression, d raised to 4 minus 1, and here it is 1 by 2, then sinus of 3x minus 1 by 2, okay, sinus of x. Then just do this time this and this time there. So yp will be 1 upon d raised to 4 minus 1, okay. This 1 by 2, we know it's a constant, okay, 1 by 2, it's a constant. Then we just keep here sine of 3x, this is fine. And here also 1 by 2 is constant, 1 upon d raised to 4 minus 1 times sine of x. Okay? For this one, we know we have to substitute where we find d squared by minus 3 squared. Here we have d raised to 4. What does it mean? D raised to 4 is d squared 2 times. Okay, so yp will be 1 by 2. And here you are going to have d squared, okay, d squared and square minus 1. Just substitute here, this here and here. Substitute them. You are going to have what? D squared is minus 3 square. Okay, and that's it. Here it is sinus of 3x minus 1 by 2. Here, if you substitute 1 here, it will be 0, like minus 1 square. Okay, like minus 1 square, it is minus 1. If you put minus 1, it will be 0. Okay, so what do you have to do here? It will be 0 if you substitute 1. Okay, what do you have to do this? Apply again. Okay, when we substitute and it is 0, we remember that we have to multiply by x raised to n, and here f of d squared must be also raised to n. Here n, for this term down, n means the number of derivative. Okay, the number of derivative is given by the number of zeros. That when we substitute this one gives 0. Okay, if we substitute 1 time and it gives us 0, then we go and put the value of d squared and it gives us 0 again. So it means that we are going to put the time of 0, the time of x, the time of derivative of f of d squared. So for this case, I will multiply by x 1 time, because 1 time putting here minus 1 square, it will be minus 1, will be 0. Suppose here, it will be minus 1. You will just substitute. If you want, just do this one. See, d square. This is d square, raised to square. Now substitute. Put here minus 1 square. It will be minus 1. Minus 1 square, it will be positive. So minus 1, it will be 1 minus 1 will be 0. So yeah, for this case, we will just add x one time, okay? We time x, and then we derive this guy 1 time too. If we derive this one time, what we are going to have? We are going to have 4d cubed. And here, sinus of x. Okay? That's what we are going to have. Okay? So, and there is also another way to see how many times this will be reduced. Okay? Just by seeing by yc. Where is my yc? Yc is here. If you see sinus of x is repeated 1 time here. That's why here it's also 1 time derived and 1 time multiplied by x. Yeah, that's why. Now see here. From here, it's okay. Now see, from here, you have this 4d cubed. Okay? What does it mean? So yp will be equal to here. What you're going to have? You're going to have 81. 81 minus 1 will be 80. Time 2, this will be 160. Okay? Sinus of 3x minus, then do this guy, this both. Okay? Here we know we have to substitute this a in d square. And here we have d square. This will be the same as x upon 4 d 1 upon d square. Okay? Sinus of x. So put here 1, and it will be what? Minus 1. Put here minus 1, sorry. Minus 1 square in the place of d square. And this will be minus only. So this minus and this minus will be positive. Okay? Just like this. Will be positive sin of x. Okay? Now see, here we have this expression, right? We are here with this expression. Now, here we have 1 upon d. What is 1 upon d? 1 upon d, it is like, we know that d is differentiation operator, but the inverse of differentiation operator is what? The inverse of differentiation operator is a, how can I say, integration function. So here you have to integrate this guy, just separate them if you feel like yp will be 1 by 160 sinus of 3x plus x by 4. Okay? Now integrate this one time. This is like 1 upon d sinus of x. Integrate this one. Integration of sin of x will be what? Minus cosinus of x. So here it will be minus, and here cosinus of x. Okay? This is your yp. Okay? Sorry. Here this and this will be 8. Okay? So here also will be 8. Nice. Now we are good. We are fine. Here it's 9 raised to 2. 9 raised to 2, 81. Okay, 81 minus this, and this is fine. Okay? Yeah. This is x by 8 time cos x, and here 1 upon 60, 0, then sinus 3x. So this is the way we solve this one, right? Okay, let's see if we have still time to solve the last expression. Okay, let us see if you have time to solve the last equation. Okay. So let's see. Okay, this last equation here, over here, like we can see, this is like dy square bx square plus 9, and here q is equal to sinus 3x, right? If you see closely, you will see that this will be many times repeated, this equation. If you see here, I have this equation is like, do you remember the particular case I showed you? Like when I told you, like whenever we have d square plus a square here, time r, it's equal to sinus of ax plus b. okay, or cosinus of ax plus b. You see this a here, this a over here, like this ax, and here you have this a, okay, sorry, you have this a also. And if the same a here is equal to this one, we know that we will substitute this square by minus a square. If I put minus a square here, it will be what? It will be minus a square plus a square. It will be 0. It will be 0. How many times 0? R times 0. So it means that I will derive and I will apply also the same. I will derive and apply derivative, because we know we have to derive the f function, f of the square function. We will derive, okay, anytime. And here I will apply x anytime also. It means that here r, I will have to repeat r time. That's why in the formula we have something like this, okay? I don't know if you remember, minus 1 for the period, like x raised to r. Then here we have 2a raised to r time r factorial, okay? Yeah, time raised to r time r factorial. And here, whenever, if it is sinus, so it will be sinus. Sinus of what? Sinus of ax by pi by 2r. Okay? Yeah. That's the question. I don't know if you remember, whether you remember or not, but that's the formula when we have this expression. But if you don't want to go to this formula, but at least if it is complicating you, just go natural way. Go the natural way, okay? The natural case. Okay, go through the natural case, and that will be fine. Because naturally, you know that here, I will have to derive, to find yp, I have to derive how many times? I have to derive 2 times, then 6 also. Okay, then 3 times. So, just look, okay? So, it will be a very long way. So, the easy way to do this is just applying the formula, and you're done. Okay? Okay. Let's first find what is our yp. Okay? First find what is our yp. Yp. Okay. Let us find our yp. Sorry. C. First, let us find what is yc. So, to find yc, we know first we have to draw the auxiliary equation. What is the auxiliary equation in this case? This will be d squared plus 9 raised to 3 is equal to 0. Now here we have to find all the roots. Like here it will be d plus 9, d squared plus 9, it's equal to 0. And d squared plus 9 equal to 0. And d squared plus 9 equal to 0. 3 times. Now here I'll get d1 and d2. This is the first pair of root. They will be, directly we can see that they will be what? They will be plus or minus 3i. They will be like imaginary number. And here also, d3 and 4 will be plus or minus 3i. And d5 and 6 will be also plus or minus 3i. How to represent this one? If you see, it is repeated 3 times, plus 3i, 3i, 3i. And it is repeated 3 times, minus 3i, minus 3i, minus 3i. So, the equation, the solution for yc will be Euler raised to, there is only imaginary part of this expression. So, Euler raised to 0x, okay? Because no real number, 0x, time. Here, if I repeat it 3 times, it will be C1, okay? Hope you can see this one. So, like, you can just come here, this one, 3 times. So, it means that, see, here I have this one repeated 3 times. Yes, nice. I mean here, 1, 2, and 3. I can have something like C1, here cos of 3x, plus IC2, and here sinus of 3x. This is for the first one. For the second, will be this, Euler raised to 0x, then C3 cos of 3x. Okay? yeah, cos of 3x, and so on and on and on. But we learned that whenever we have equal roots like this, okay, we can write something like this directly. This will be c1 plus c2x plus c3x squared cosinus of 3x. Okay, we learned this one. Okay, for repeated roots, then plus I c4 plus c5x plus c6x squared, then here sinus of 3x. Okay, yeah, that's the way we write for this solution. Okay, now you can see this. If you're not able to see this, I will write here down. Okay, this will be c4. Okay, I c4 plus c5x plus c6x squared. Okay, and here sinus of 3x. Okay, this is the solution for this case. Okay, YC. Now let us find what is YP. Just try to record this one because I'm lack space. I will need space to solve this one. Now, how to find what is YP? YP will be 1 upon, we know that is like d square plus 9. We know what is 9. 9 is what? 3 square. And it is raised to 3. Then we have sinus of 3x. So see, whenever I have this expression, I just compare, okay, this expression is directly this one, d squared plus a squared, and here it's equal to sinus of ax plus b. If you compare this, so the solution for this guy will be directly the formula, like pi will be minus 1 raised to r time, it is raised to r, just put me here r, time x raised to r upon 2a raised to r and r factorial. Then here sinus of the same expression, ax plus pi by 2 r. You see? And this is the same we are going to have here. Here it's the same. Okay? So directly I can apply just the formula. Yp will be equal to 1 upon, but here it's 3. Okay? It's 3. So it is 3 also. So the formula will be, who is your r? Here we know r here is 3 and a is 3. Okay? Just like this. So 3, 3. Then you can apply. This will be 1 upon, minus 1 raised to 3. Okay? Minus 1 raised to 3. Then x raised to 3. Here down, we know, just follow the formula. Here down we have 2a. 2, what is a? A is 3. Raised to 3 raised to r time 3 factorial. Then here it will be sinus of 3x plus pi by 2 r. What is your r? R is 3. Okay? Yeah, this way you will economize much more time, and this will give you the direct solution. Here it will be minus, here it will be x raised to 3, here it will be what? 6 raised to c raised to 3, it will be 6 raised to 3, this will be something like 216, I'm not sure. Yeah, let me just try. 6 and 6. This time this will be 6, 3, 11. 18 times, yeah, 21, nice. Then if you multiply this by 3 factorial, it is 6 again. So 216 times 6 again, this will be 6, 3, 6 plus 3, 9. This one will be 12, yeah, this and this, yeah, this will be 12. So 12, 19. So 12, then again it will be 96. Then sinus of 3, this one. Okay, if you don't feel comfortable, you can just solve this one. This is a very good expression. See, it will be the same, 3x. It's like 3 pi by 2. Okay, pi by 2. See, here you have to understand a bit of trigonometry. We know that 3 pi by 2, 3 pi by 2 is here. Okay, and this is 3x. So if you add 3x in 3 pi by 2, it is 3 pi by 2, and I add plus 3x. Plus 3x. It means that the angle will lie between this guy, this quadrant. That's the question, the point. So, as long as this is pi by 2, it means that sinus will have to change to cosinus. Okay? Yeah, sinus will have to change by cosinus. If it were only pi, sinus would remain the same. Whenever I add an angle to pi or pi by or 2 pi or like 4 pi, 3 pi, 5 pi, 6 pi, okay? Whenever I have an addition, let me just write here this note. If I have like x plus k pi, this k is a integer number, whatever integer number. So if I put here sinus, it will be equal to it will be equal to sinus itself. Okay, now the only thing you have to understand is the sign will change, because here you have to analyze for what? Pi, okay, for angles that are greater than pi, okay, just like this. So if you put here, pi is here, angle greater than pi will be between this. So analyze sinus between this quadrant. Sinus between this quadrant is negative, so it will be negative. If it were cosinus, the same. You should go for the same pattern. But if it is pi by 2, you have to change. Will have to change. If it is sinus, x plus pi by 2, this sinus will be equal to cosinus. If it were tangent, will be cotangent. If it's cotangent, will be tangent. If it is cosinus, will be sinus, and so on. Then analyze which quadrant and the signal of the quadrant. Very easy. Now see, x plus pi by 2. So x pi by 2, let's see, pi by 2 is where? It is here. Pi by 2 is here. Now, add x, I add x. This is in the second quadrant. Sinus in the second quadrant is positive, like you can see, up, positive. So it will be plus cosinus. The same here. Just do this one, we know, okay? As it is pi by 2, so I know that sinus will be cosinus. Now, it will be cosinus of 3x. Now see, what is the signal of sinus? Sinus here down is negative. So here it will be negative. Just like this, negative and negative, it will be positive, all of them. Okay? And this guy will be this. Okay? And it's done. It is solved. Okay? Hope seeing you in the case number 3. Bye.